Hey everyone, this will be another video about the blueprints that underlie the advanced turn-based tile toolkit. This video will be all about artificial intelligence, and as artificial intelligence is encapsulated within the ability blueprints and the ability component in this toolkit, it will also be about the ability system in general. So make sure to see my video on the ability system if you have not done so already. So to explain this, I will both be going through the blueprints as I have done previously, but I will also be going through it using breakpoints and looking at values and how stuff changes as the AI is evaluating its actions and landing upon the best decision on a particular turn. So to make this demonstration easier to follow, let's set up things in this level so that the AI has a limited amount of options to choose from, and then we can go through the ability systems or the ability blueprints event graphs and see how the AI makes its decision each step along the way. So let's just keep a couple of units here and one AI unit, this guy. And then we can change the health of this guy so he's more damaged and should be a more tempting target to attack if we are using the ability move attack ability, which we are here, which is set up to prioritize attacking units that have lower health. We're gonna look at that in a minute, or we can do so now by clicking play. And if we just end our turn, we can see that he moves far away and shoots this unit here. So he chooses to attack the unit with the lowest health, and he chooses to go his maximum range away from him and attack him, because that's how this guy is set up, and we are going to look at how. So let's look at the default ability, find it in the content browser, so it is within core and abilities, and there's BP move attack. If we look at this ability, let's see, so there's stuff here that's on player activate, and also if the AI has found no valid target, but not the stuff which is at the very beginning of activation for the AI. So for this ability that has not been overridden, so we have to look within BP ability, the parent blueprint, and here we can see during activation, we went through this in the last video, but we branched off here because after we have then assigned this ability to the unit, we've updated the attributes that are stored within here and so on. Then we check, is the unit that has activated this ability AI controlled? And if it is, we go here. So this is where we're going to start. And we can actually look at this using the built-in debug tools for blueprints to step through one at a time and see how the values that are stored within this ability changes as it makes its decision. So to make this easier to see what's going on, let's enable displaying the grid indexes on these tiles first. So to do this, I set pre-generate gameplay grids to true, which is necessary so that the grid manager generates all of these locations beforehand, so we have access to those in the viewport now. And then display tile indexes, so we can see that these player units are placed on index 63 and 143, while this AI unit is placed on grid index 106. So now let's add a breakpoint to see what happens when this AI unit decides. So we can go to BP ability, and this is activate, and this actually calls the parent activate. So to make this more thorough, let's go to here first, and I'm gonna add a breakpoint here. Now if we start, then this should break when it's activated for our player unit, and then I end turn, and then the ability is activated for this next unit, so we hit resume again, and when I end the turn, then it should be activated for this guy. So now this AI unit has just activated BP ability move attack. If you do not realize why this unit activated this ability now when I ended the turn and this turn started, then look at my video on the turn manager. So let's see where we are. So here we can step through and we can skip like 1 frame at a time. So this stuff we've already gone through, right? So nothing relevant specifically for the AI happens here. So we can just continue skipping, and then we are into BP ability, and here we cast to BP unit. We check if the unit that activated this ability is, or the actor that activated this ability is the unit, and it is. We assign the ability to the unit and so on. But the stuff we want to look at starts here, so let's resume and jump over here. So is this unit AI controlled? This should be true, and it is. And then we check reassess. This is something that can be reassess 2. I should move that too. This is something that means, should we, when this ability is activated, should the AI try to assess the value of this ability? I'll go into what that means like now, or should we just use whatever values were assigned the last time this ability was activated? And this is something that can be useful if when we're using the ability system, the component, the ability system, because there we look through, or the AI looks through all abilities it can use, it assigns values to all of them, and then it activates the one it thinks is best. And at that point we have already assessed the value and found the appropriate target for this ability, so we don't want to do that assessment again, and then this can be false. But generally you want this to be true. So it should be true now, and it does. And then we bind an event to onAbility assessment done. So onAbility assessment done, that is an event dispatcher that is called when, well, the accessibility value, all the stuff that happens here is done, then this is called. And when, since we bind this event to when that is called, this event is going to happen after all of the stuff in here is done, provided we call the ability assessment done event dispatcher after all of this is done. So if you don't know anything about event dispatchers, then you can find tutorials on that other places, but basically they are things that can be added to any blueprint by using add new, just like with variables and functions, but then you add an event dispatcher instead, and those are events that basically shout out to all other blueprints you have placed. And if you have bound any events on any blueprints anywhere in your level to this event dispatcher, then all of those events will fire when you call that event dispatcher. So they're very useful in that regard. Why I'm doing that here instead of simply moving on, just connecting this over here, is because due to some of this AI assessment, it can be pretty heavy, and if you're doing some very complicated stuff, then you might want to spread it over multiple ticks. So if you just connect this onwards, then that's going to keep going on the same tick. It's going to instantly happen after this is done. But if there are delayed stuff happening within this assessment, then it's going to continue before it is done, and of course that's not what we want. But yeah, so let's see what happens within assess ability value. You can see here we're passing in the owning unit, and we're saying that we are do not want to get a specified target. This has the option that you can say, I only want to assess the value of targeting this specific like grid index. So if we input 143 into here, or like got the index of this guy, which would be the value 143, then this AI unit would ignore this unit and all other units when assessing this ability. It's useful in some cases, but now we want it to assess everything it can. So we're gonna keep going into accessibility value. Now this is an event that is defined by BP ability, so you will note that there's no such event or no AI functionality in the ability base blueprint. So all of the AI stuff is in the BP ability blueprint by default. So yeah, here we do some of the same stuff we generally do. We set the owning unit to unit. I mean, this was already done when the ability was activated, but maybe you want to assess the value of an ability without like activating the ability. So here's an option that does that. We set the owner, update the attributes, all of this stuff we generally, or we also just did when activating the ability. Then we check the requirements of this ability, and this can be if you have any sort of requirement you need to be satisfied for this ability to be valid. So for some of the abilities that are used in the Jungle Raid Advanced Tactical map, some of those assume that you have like the cover system implemented, and if you don't, then the functionality is going to break. So we do a check here. This is a function that can be easily overridden by various ability blueprints, so you can change what requirements are for this specific ability. If we look into this, we just check that the only requirement is that the owning unit has more than 0 action point. Now, if we had overridden this function with something in ability move attack, when we debugged and stepped through all of these nodes, it would have jumped to that definition in ability move attack. But since it doesn't, it uses this default definition here. So this should be true since we just activated this unit, and it is. And then we go to one fairly heavy duty function here, or this is like the first step of the decision making to do a very kind of rough sorting of the potential, like possible targets that can be targeted by this ability before doing some more filtering and figuring out more specifically which target it wants to use this ability on. So we have a lot of input for this. We have the source index, just it should be generally, I mean, where is this ability activated from, and this will generally be, you know, the index that the owning unit is currently occupying, which would be index 106. And we insert also the possible move of this unit and the range that it has. These are values that are calculated within this ability beforehand. So this is to get, if we add together how far this guy can move and how far this guy can shoot, then we should get all like potential targets it can attack. If any other unit is outside of that range, we will obviously not be able to target that unit with this ability, and we can ignore it. So this is like one of the first steps in the filtering. And we also input, do we have a diamond shaped visibility for a square grid where we want to see like in a diamond in some sort of games. Relevant factions, so what factions should we ignore? What factions can be targeted by this ability? And the default here is that you get all the allied factions of this unit, and then if use on allies is false, which it is by default, abilities are set up to be used on enemies, then so if use on allies is false, then this will be true because it's not, and then we find the factions that are not in array. That means that we look for all units that are not on the allied faction list. In other words, we're looking for enemies. And then do we want to exclude a specified unit? And by default this is set up so that it excludes itself, so that it cannot target itself. This can of course be changed if you have some sort of like heal ability that you want to be able to target itself and so on. And we have the find specified target. Do we want to just look for one specific target, or do we want to look for all potential targets? And that is input from the stuff we got earlier here. In this case, this is -1, which means that we want to look for all possible targets. So let's keep going in here and see what happens. This is also still within the grid manager. So first, find potential targets. And without going into this in detail, this is what I talked about, where you get the move plus the range and you see everything that can potentially be targeted as like a first filter. And this is a good thing to think about when designing things that are like processing heavy, like AI in this case. Start with stuff that's quick to calculate and do like a rough sorting, and then try to exclude different targets as quickly and efficiently as you can, and then from the stuff you keep you can do more and more complicated and processing intensive stuff. So let's just jump over the specifics here. And we check, did we find any valid targets? Let's see, and that is true, so we can see here that's true. And we also have an output of potential targets. Okay, we have one that is at 143 and 63. So we can see that we now have found these two targets. So both of these are contained within the ability. Let's see, where are we? Yeah, here. And then So we did find valid targets, and we now have some potential targets stored in this set. Then we check, is the ability system component valid in this unit? In this case it's not. In the next video we're going to look at the ability system component where it's a bit more advanced. So in this case we just go here. It will skip from here instead of doing this stuff, and then it will run pathfinding from this unit using its possible move, and then it will keep targets in sight from the move array. So first we just checked, okay, these units can potentially be reached, but now we want to check, can they actually be reached? And this happens by then this unit calculating pathfinding around itself, and then looks at these units and then checks indexes, grid indexes around this unit to see, are any of the grid indexes within the attack range of this ability of this unit overlapping any of the indexes we can move to. And if so, as soon as it finds one such index, it says, okay, that means that there is at least one index we can move to that also has line of sight and is in range of that unit. And let's just demonstrate how that would be to make that easier to understand. So let's just make a copy of this guy, put him all the way over here. Let's just block him in so that he cannot be reached and cannot be seen, like this. So now if we add a breakpoint, let's see here, he should still be as one of the potential targets, and let's look where he is. So he is at index 7. So yeah, let's just end the turn, all of these, and now let's see, let's get back to where we were here. So did we find a valid target? That should still be true, yes. And now we have found, and you can see that 7 is included here as one of the potential targets. So because he is within the move and attack range, even though he's blocked out, but we haven't checked for this yet. So when we then keep going, and then we run the pathfinding, and we keep targets that are in sight from the move array, and if we skip to here, then now, yeah, he's still here. And why is that? That doesn't make any sense. Of course. I just realized, well, I won't remake that. This is also useful information. The thing is here, since we did pre-generate these gameplay grids, and then I place down these walls, that means that the grid manager will ignore all of these walls, since we pre-generated the grid and the edges before we pressed play. So I have to then uncheck this and check it again, and now it should work. Let's see. Yeah, now we can't move out here anymore, and there we are. Okay, so now we only keep 63 and 143, so these two guys. Great. So here's some stuff for optimization for big units. We're gonna look into that in a big unit video later. So in this case we just keep going. So we have these targets, we have at least one of those, so we're saying, yeah, we found valid targets, and we output the target indexes that we found, and we also output this pathfinding map that we generated. So we do not need to run pathfinding a second time, since we've already done it once. Keeping on then, we see, did we find valid targets? Yes, we did. And now we evaluate these targets. So we look at all of the potential targets and we try to figure out what is the best target for this ability. And this can be defined however you want within the specific ability. Let's check. So here's the target evaluation function. So we input these targets, we convert it to an array so we can loop through it. And then for each of these targets, which will be, let's just skip so we can look at it, which will be index 63 and 143, we run this find target value, which is generally overridden within the specific ability. So let's see if it is just that. Oh yeah, we're going into the macro. Let's just step out of this one. Oops, step out. Yeah. we're finding the target value. So if we frame skip, we see that indeed this function has been overridden within the move attack ability and is not within the BP ability in this case. And you can see it here that find target value is one of the functions that was overridden. So we find the target value. How do we do this? Well, it's very simple in the move attack. It finds the unit that occupies this index within the grid units map in the grid manager, and it checks what is its current health. It takes 1 divided by its current health, gets the minimum of this and 1, and output this. So that means that this will always return a value within 0 and 1, which is what I do for all value assessments within the abilities. The assessments are going to work even if you have values that are higher than 1, but it's useful to have everything on the same scale sort of when you're designing abilities. So I would recommend having all of these calculations return a value within 0 and 1. So what this means essentially is that the higher the health of this guy is, the less valuable it's going to be. The lower this value output value is going to be. So if we go back here, and after we've found the value of all of these targets, we should have this choices array which is filled up, and we can see here that one of them has a value of 0.014 and something, and the other one 0.01. And this is ordered in the same order as this array here of the indexes of the units we are checking. So that means that the unit that is standing on tile 63 has a value then of 0.014. So he has been assigned a higher value than the other unit that is placed down here, and this will be prioritized as the one to use the ability on, which is what we want in this particular ability. Feel free to play around with what happens within the find target value to change it so that the unit wants to attack the unit that has, say, the lowest move or is the closest to the current unit or whatever. You can change this to be essentially anything. Then continuing on, we just set up some temporary holding values here of these indexes and the targets. And then we want to check, do we want to use tile values? So this is a thing where you can, you're not just assigning a value to the targets, but you're also actually assigning a value to the various tiles you want to stand on. So this is heavily used in the advanced tactical example where I used the cover system, because there you want to prioritize getting behind a tile that has cover. Compared to standing out in the open, and then in that case you get the product of the value of the target and the value of the best tile that you can stand on to target target from. But in this case we're not using tile values. That's more used in the advanced abilities that I'm going to look at in the next video. So in this case this should be false, and we go down here. So in this function we're finding a path to the tile in range. So essentially we are, if this is the unit we want to target, we're figuring out, okay, where do we want to go to attack this guy based on some priorities we have set up. And for this guy, he's prioritizing actually moving as far away as he can. We're going to look into that. But yeah, so this is from the grid manager. So what targets are we targeting? Well, in this case, since we don't care about the values of the tiles themselves, we just get the max value of these targets, and then we find the target index that corresponds to that value, which is, well, it should be, we can't see that until we've jumped to the next one actually, but this is going to be then 63. So target index will be 63 from the grid index, which is where we're currently standing here. We have a range input and diamond shape visibility, all of that stuff, and we have the preferred range. So this is something that is set up within this unit. I can show that actually. Let's add a breakpoint here. So if we look at this guy here, he should have a preferred range variable. You can see that this is set to long range, which means that Yeah, like we saw in the beginning. Oops, yeah, I have all of these breakpoints set up. He's going to move to long range. If instead we set this to, say, close range, yeah, that doesn't work. Yeah, that's one of the reasons these auto units are a bit tricky, because in the construction script of this guy, he's set up to this preferred range based on its based on the range of this unit. So let's just override this, just ignore this, and then we can set this to close range. Yeah, let's just disable these breakpoints as we go. And there we are. Okay, and now he's going to be moving as close as he can. And well, the last one that's set up, which is short move, so he's lazy and he prefers to stay put where he is. And we can see that here. So these are like some basic AI preferences that are easy and quick to process, and yeah, so do not take into account the values of the tiles, but just where the unit prefers to be in the relation to its target. Okay, so after doing all of this, let's see, yeah, let's just increase the initiative so we don't have to jump over all of these other guys every time we start up there. Okay, so he finds the path of the tile in range, the preferred range. Well, currently it's short move, as you can see, and I won't go into detail of what this function does, but you can look at that, and I will in a separate video. That's actually in my old blueprint video. The 5th tutorial goes into that. That function hasn't changed that much. Then let's see. Yeah, can't I just, let's see, step over? Yeah, that works. And so we set the move target index is now 106. What is that? That is, oh yeah, we can't actually, yeah, this is here, of course. Since we're standing put, then the target that we want to move to is 106. Earlier, when we had the preferred long range, that might have been 108, say, if it's attacking from this tile. And the target index, let's see, is 63, as we would expect. And then it returns the value after this ability assessment is done, which is the max value of this target. So it's not modified by anything else, which it would be in this more complicated setup, which I will go into in the next video. So now we're back where we were earlier, because yeah, we just called this event dispatcher, which we bound to an event earlier. So when we called it, now we're back here. And then it's important to unbind this event so that the next time this event over here is run, the event dispatcher is run, we don't necessarily want to run this specific event. So it's good practice to unbind it. And then we check, is the value of this target greater than 0? At the moment it's 0, but we need to step ahead to get its actual value. We can see that it's higher. So if it is, then we keep going. Now the ability system is set up so that if something has a value of 0, we consider it to be as bad as doing nothing. If it's lower than 0, then we consider it worse than doing nothing. So if this is greater than 0, we want to do this ability. If not, we just want to end the turn by default. This is if you're not using the ability system, in which case the ability system component, in which case you are kind of comparing a lot of different abilities to each other, so you don't want to end the turn there. So that works a bit different, but we'll look at that in the next video. In this case, we are just assessing this specific particular ability, and so if the value is better than doing nothing, then we want to do it. Then we have, and this is just for show basically, that you have an activation delay of a second. So after the AI is activated, we have set it up so that it delays a second before it goes through with activating its ability. That's just to make things feel a bit less rushed, so that the camera has time to pan over to the AI unit before it gets to act. Then we do an actual AI activation delay. So this is a delay that is within the actual event graph. So this is something that ensures that, yeah, as I've described here, that there's at least a minimum of time within each AI unit that is activated. So let's see that you have lots of AI units here, and all of them, you have like 20 AI units placed in your game, and none of them have a valid target. And then all of them want to, they try to find all the units in range, they try to calculate the best unit and so on. And then within the same tick, basically, they jump one to the other and try to do all of this calculation, and that will slow the game down naturally if you're doing a lot of that stuff at the same tick. So therefore, there's a slight delay here. And after that, we run the AI activate event within this ability. And let's follow that. So we have an AI activate here. So at this point, we know that this ability is going to actually be activated. And then we check, is the grid index, so the index currently occupied by this unit. Yeah, let's see. Let's actually get here at the breakpoint. There. So is the grid index that is occupied by this unit 106, is it different from the move target index? And since we just set this up so that he wants to move as little as possible, it actually isn't different. So then it just keeps going to attacking. So let's change him back so that we can see how some more of this stuff works actually. Let's set the preferred range back to long range. There. Okay. So now in this case, his grid index is different from the index he wants to move to. He wants to move to index 147, which is, yeah, right down here, and it's different. So since the move index we want to go to is different than what we're currently occupying, naturally we have to move there. Now, if you recall from earlier, this move target index, that was stored when we evaluated this ability earlier. So we don't need to calculate this again, because we calculated this as we were finding the best target and calculating the value. So we don't need to do all of that once more. So then we pay the move AP costs, as explained in my previous video. And also we move to this particular index. And then we check after moving, is the owning unit still valid? So this is a check, so if we die on the way, we don't want to try to activate the ability then. Let's see, so then we pay the AP cost. Let's just follow this in real time. And then we check the target index, so the one we want to use the ability on, in this case to attack him. Is it different than -1? So essentially, is it valid? Do we have a valid target? So if not, we just want to reactivate this unit. If it is, then we want to execute this ability and afterwards deactivate the ability. Similar to what you would see in the player activate or the input stuff for the player using the ability as described in my last video. So we execute the ability, which is generally always overridden within the specific abilities. And in this case, this means, okay, the target, is it a unit? I mean, does the grid unit map contain this target index? If it does, then we want to queue an attack action, and we want to do the take damage function on that particular unit, and then we want to hide the target marker. So that's how that works, and let's see him actually do this in action. He moves over there and he shoots him. Fantastic. So those are the basics really, but let's look at a couple of different things that might happen. Now let's see that we have no valid targets. It's just this guy here. And then you see it just switches away instantly because he decided that there's nothing he can do. There's no valid target. We can find out at which point this branched off. by going to the accessibility value. Let's see, the first possible branch is here that can fail out, so let's try that. So in this case we check the requirements, so the requirements are still okay. We find all possible targets. Now this is where it should fail. So in this case, did we find a valid target? No, so we go to the found no valid target event, and that's actually defined with a specific override within ability move attack. And why is this? This is because if we do not find a valid target, we actually might want to move towards that target anyway. And in this case that's going to fail too, but we can look through this anyway. So we check again, just do we have more than one action point in this case? So are we able to both move and attack essentially, which is how it is defined within this specific ability. Then we check find the closest unit in move range. So okay, we didn't find anyone we could actually use the ability on within range, but let's keep searching until we find at least one unit and try to move towards that unit. So in this case we have a max search range that is set up, which is 60 by default in this unit. So it keeps searching and searching, pathfinding, until either it finds a unit, or it goes to a range of 60, or it has no more tiles that it can search. Since this map is a lot smaller than the move range of 60, this third thing is what's going to happen, because we have no units that we can actually reach. So here we keep running pathfinding and pathfinding until nothing is found, or something is found. In this case nothing. Target found is false, and then we call ability assessment done with a value of 0, which means that using this ability is just as bad as doing nothing, and we do not use this ability. Now let's look at, let's see, yeah, if you have this guy here, but you also have another guy who's way over here, so we still can't reach him, but we might want to go closer to him. And in this case still we found no valid target, and then we find the closest unit in move range. Let's see if this is true. It should be, and we did find a target actually, and the closest unit index is 379, which is probably what this guy down here is occupying. It should be, if everything is right. We find the path to the index. Well, yeah, we find the path all the way to this index, which is of course further than what we can actually move, and then we find the reachable index that's closest to the target. And for this index, if we find a relevant place here, then we move to that, or we set that as the move target index. We say that we have no target index to actually attack, and then we call on ability assessment done, at which point all of this stuff happens with AI activate, where we have a valid move target index and we move, but we do not have a valid target index, so we stop without executing the ability. So let's see that in action. Whoops. Yeah, you can see he tries to move towards this guy. Who was on index 379, as we saw. So when we found the path, he was essentially then looking outwards, pathfinding like a few steps at a time until he found this guy, at which point he found the shortest path to this guy, and then within that path he finds the index, which is has a movement cost that is as low as or as low as or lower than the movement of this particular unit. So that's going to be it for this video. If you want to play around with abilities, some abilities to look at are in core and abilities. The attack and move abilities are a bit simpler than the move attack ability, so these are good things to look at if you want to try to modify them and figure out how all of this stuff works for yourself. In the next video, like I said, I'm going to look at more complex abilities, but then in a later video I'm going to be making a new ability from scratch where you can follow along, which will hopefully help in making it even clearer how all of this works, to give a bit more of a practical example. But for now, that's it.